Well, here's another example of graphing an exponential function and its inverse. Before I get started on these problems, I always like to sketch in the line y equals x. That's the line of mirror symmetry between a function and its inverse. And it'll be vastly helpful in graphing these two functions. So this problem is a great example of why you should remember your function transformations. This function f of x is equal to 3 to the x minus 2 is really just a simpler function. G of x is equal to 3 to the x, so we could call that its parent function, translated to the right by 2 units. So if we look on the graph, a normal, well, g of x in this case would pass through the point 0, 1. As all simple exponential functions do, but this one is translated 2 units to the right, so it's going to pass through the point 2, 1. Then everything else is pretty simple. It's going to have exponential growth properties on the right side of that point, and then on the left side it's going to approach the x-axis asymptotically because there's no shift up or down. Now it's time to find the inverse of this function. So we'll write y is equal to 3 to the x minus 2. So x is equal to 3 to the y minus 2, just swapping variables. Now to solve for y, I'm going to take the log base 3 of both sides because I want to find the true inverse of this function. So that's why I need the log base 3. Now the log base 3 of 3 to the anything is just that thing. So on the left side I have the log base 3 of x, and on the right side I just have y minus 2. So finally, the inverse is y is equal to, I'll say, 2 plus the log base 3 of x. So we have f inverse of x is equal to 2 plus the log base 3 of x, and then we have f of x, which we already graphed. Now using transformations again, just notice that this is a normal log function, just shifted upward by 2 units. To graph it, I'll mostly just take advantage of the mirror symmetry. It's got to come through here just about like this and then approach the y-axis asymptotically. And then if the point 2, 1 is on the graph of the function, then the point 1, 2 has to be on the graph of the inverse. And that looks just about right.